This is section 2-3, and the title of it is Savings Accounts. And our quote is, "Anything that we can do to raise personal savings is very much in the interest of this country." And this was Alan Greenspan, a noted economist, and for a while he was head of the Federal Reserve, and so he pretty much knows what he's talking about. The objectives: define the basic vocabulary of savings accounts and compute simple interest using the simple interest formula. Here are some key terms that we need to understand and know the definitions of. First of all, is simple interest. This is interest that is calculated on the principal in an account using the formula I equals PRT, and we'll learn more about that as we go along here. Statement savings. These are accounts where you receive a monthly statement showing all activity, including deposits, withdrawals, interest earned, and any fees. Minimum balance. This is a certain amount of money that must be kept in an account. A money market account is an account with a higher interest rate that usually requires a greater initial deposit and a higher minimum balance, often with a minimum number of transactions per month. Then we have certificate of deposit, or CD, a certificate that states you have a specific sum of money on deposit and guarantees payment of a fixed interest rate after a period of time. Deposits and withdrawals cannot be made with a CD. Then maturity, that's a specific date when interest is paid on an account. And lastly, arithmetic sequence. This is a progression of numbers where the difference between any two consecutive terms is constant. All right, let's look at an example here. Lisa has a glass jar in her office that she is going to use to collect coins. She starts by putting in $11.25 in coins she already has. She pays for a commute to work each day and receives 70 cents in change. She will add the 70 cents into the glass jar each workday. After 100 workdays, she will take all the change and deposit into the bank. How much will she have after 100 workdays? All right, so what we're going to do here is we're going to use something called an arithmetic sequence, okay? And this is where you have a formula: a sub n is equal to a sub 1 plus n minus 1 d. A sub 1 is simply the first term, n is the number of terms, and d is the amount increasing or decreasing. All right, so number of terms, it's going to be 100, okay, because she's talking about 100 work days. All right, initially, she's going to have $11.25 in the jar. And then she's going to add 70 cents every day, okay? So that's going to be the difference. So that's the difference, 70 cents. 100 work days is the number of terms, that's n. 11.25 is the first term. So if we plug these numbers in, after 100 days, okay, she's got her initial 11.25. The number of days is 100. We subtract 1, and the amount she puts in is 70 cents. And how much she will have after 100 work days is $80.55. All right, let's look at example 2. Raul's savings account must have at least $500, okay? So that's the minimum balance, or he will be charged a $4 fee. His balance is $716.23 when he withdrew $225. What was his new balance? All right, so let's take his original balance of $716.23. We're going to subtract the amount he withdrew, which was $225, and that's going to leave us with $491.23. But that is less than $500. So he's going to be charged a $4 fee. So that's going to be taken out of his account. So now we take this new balance here of $491.23, and we subtract $4, and we get a new balance in his account of $487.23. Now, if after a certain length of time he doesn't bring that back up to $500, he will be charged another $4 fee. Typically, that's going to be once every month. All right, let's look at example 3 now. Mitchell deposits $1,200 in an account that pays 1.5% simple interest. Okay, notice that we're talking just simple interest. This is not compound interest. He keeps the money in the account for 3 years without any deposits or withdrawals. Okay, just sits there for 3 years. How much is in the account after 3 years? All right, now, notice we said this was simple interest, okay? So we're going to use the simple interest formula. The simple interest formula simply states I is equal to PRT, or I, which is interest, P is your principal, or in other words, your starting money, R is the interest rate as a decimal, and T is time. All right, if we plug in our numbers, we got $1,200 is the money he starts off with. Okay, so there's the $1,200 right there. The interest, 1.5%. But remember, we must change that to be a decimal. So that's going to be 0.015. We move the decimal point 2 places to the left. And lastly, we've got 3 years here. So we multiply by 3. And we come out with $54 in simple interest. Now, this is the amount he gets in interest. But how much is in the account after 3 years? So we take our $54 interest, add it to our $1,200 principal, and we come out with $1,254 is now in the account after 3 years, provided there were no deposits and withdrawals. All right, so let's look at example 4. How much simple interest does $2,000 earn in 7 months at an interest rate of 2%? All right, so again, we're talking about simple interest, all right? So we're going to use the simple interest formula. Again, what we used before. Now, the only difference is, principal, we got $2,000. Interest rate is 2%. Now, time, however, is 7 months. Normally, time is given in terms of a year. So the time is 7 months, which is equal to 7/12 of a year. 12 months in a year, 7 of them, 7/12 of a year. We convert 2% to a decimal, and here we have our formula right here. I is equal to 2,000 times 0.02 times 7/12 to get the interest, the amount of simple interest, and the amount of simple interest is simply $23.33. All right, let's look at example 5. How much principal must be deposited to earn $1,000 simple interest in 2 years at a rate of 1.3%, round to the nearest cent? So here, we're not asking for interest, we're asking for principal. So we're going to start with our I equals PRT formula, but as I say, we're not looking for R, we're looking for P. So if we solve for P, we get, divide both sides by RT, we get the principal is equal to the interest divided by rate times time. The interest, $1,000, so that goes up top here in the numerator. The interest rate, 1.3%, but remember we're going to treat that as a decimal, move the decimal point 2 places to the left, and it becomes 0.013. And then the time is 2 years right here. So therefore, the amount of principal that you have to deposit is right here, $38,461.54. If you deposit that at 1.3% interest for 2 years, you'll get $1,000 in interest. Now on to example 6. Derek has a bank account that pays 2.1% simple interest. The balance is $910. When will the account grow to $1,000? Well, if the account grows to $1,000 and it was $910, that means he's got an interest of $90. So 1,000, minus 910, that means his interest that he's earned is $90. All right, now notice it says when. So this wants to know a time. So again, I use my I equals PRT formula, but this time I solve for time. So T, if I divide both sides by PR, becomes I divided by PR. So the interest, we figured already, was $90, okay? So that's what goes up top here, all right? The principal was $1,000, okay? And that's what goes down here. And the interest is 2.021, so therefore you come out with approximately 4.3 years. Now, if I take the 4.3 years and convert that to months, 12 months to a year, that means it'll take 51.6 months to take and for the account to grow to $1,000. All right, another example. Kerry invests $5,000 in a simple interest account for 5 years. What interest rate must the account pay so that there is $6,000 at the end of 5 years? All right. So therefore, we've got 6,000 minus 5,000. That means you want to earn $1,000 in interest, okay? All right. We want to know the interest rate. What interest rate? All right. So again, if we use I equals PRT, divide both sides by PT this time, we get the rate is equal to the interest divided by the principal times the time, okay? So the rate is equal to 1,000 divided by 5,000 times 5, comes out to be 0.05. Remember, that's a decimal. Move the decimal point 2 places to the right, and therefore we've got a 4% interest rate. Now, an important thing to understand, all the examples here are simple interest. In reality, that's not going to be very accurate in today's world. Very few accounts are going to pay you simple interest. But you need to understand simple interest before we can go on to compound interest, which will be in the next unit. So just understand that these examples are somewhat simplistic. Simple interest is not something that typically you're going to see in real life.